8086 microprocessor is an improved adaptation of 8085 microprocessor. It was planned by Intel in 1976. It is a 16-bit microprocessor having 20 address lines and 16 data lines that give up to 1 megabyte stockpiling. It comprises of a groundbreaking guidance set, which gives activities like augmentation and division effectively. It underpins two methods of activity, for example, the most extreme mode and minimum mode. The most extreme mode is appropriate for a framework having numerous processors, and minimum mode is reasonable for a framework having a solitary processor. The most conspicuous highlights of an 8086 microprocessor are as per the following: It has a guidance line, which is equipped for putting away 6 guidance bytes from the memory, bringing about quicker handling. It was the initial 16-bit processor having 16-bit ALU, 16-bit registers, inside data transport, and 16-bit outer data transport, bringing about quicker preparation. It is accessible in 3 variants depending on the recurrence of activity: 8086 5 MHz, 8086 to 28 MHz, 8086 to 110 MHz. It utilizes 2 phases of pipelining, for example, get stage and execute stage, which improves execution. Bring stage can prefetch up to 6 bytes of directions and stores them in the line. Execute organize executes these guidelines. It has 256 vectored interfares. It comprises of 29,000 transistors. Size: -8085 is the 8-bit microprocessor, while 8086 is a 16-bit microprocessor. Address bus: -8085 has a 16-bit address transport, while 8086 has a 20-bit address transport. Memory: -8085 can access up to 64 kilobits, while 8086 can access up to 1 megabit of memory. Guidance: -8085 doesn't have a guidance line, while 8086 has a guidance line. Pipelining: -8085 doesn't bolster a pipelined engineering, while 8086 backings a pipeline design. I/O: -8085 can address 2 to the power of 8 equals 256 I/Os, while 8086 can get to 2 to the power of 16 equals 65,536 I/Os. Cost: the expense of 8085 is low, while that of 8086 is high. A microprocessor is an integrated circuit with every one of the elements of a CPU. In any case, it can't be utilized standalone, since not at all like a microcontroller, it has no memory or peripherals. 8086 doesn't have a RAM or ROM inside it. Nonetheless, it has inside registers for putting away middle-of-the-road and conclusive outcomes, and interfaces with memory situated outside it through the system bus. 8086 provides the programmer with 14 internal registers, every 16 bits or 2 bytes wide. The internal architecture of Intel 8086 is divided into 2 units. The Bus Interface Unit, BIU. The Execution Unit, EU. These are explained as following below. Bus Interface Unit plays out the accompanying capacities. It produces the 20-bit physical address for memory to get to. It brings guidelines from the memory. It moves data to and from the memory and I/O. Keeps up the 6-byte prefetch guidance queue. Supports pipelining. View mainly contains the 4-segment registers, the instruction pointer, a prefetch queue, and an address generation circuit. The principal parts of the EU are general-purpose registers, the ALU, special-purpose registers, the instruction register and instruction decoder, and the flag register. Brings instructions from the queue in view, translates and executes number juggling and rational activities utilizing the ALU. Sends control signals for inward data move tasks inside the microprocessor. Sends demand signs to the BIU to get to the outside module. Enough of the basics of 8086. Let's see how much we learned so far.